Hello everyone. Today we are going to discuss about unsupervised pre-trained networks as the part of the fourth unit. Let us go with the syllabus. As per the syllabus, we have the first topic, major architect. Actually, this unit deals with the major architectures of deep neural networks or deep learning, and as the part of that, it was started with the unsupervised pre-trained networks. So we didn't cover this topic and we directly went to the CNN and we discussed about the CNN in detail. Most of the concepts of the CNN are covered already in the previous sessions. So in this session we are going to discuss about the unsupervised pre-trained networks. So before going into that, what are the major network architectures in the deep learning that we should have a look on that. That is unsupervised pre-trained networks, convolutional neural networks, recurrent neural networks, and recursive neural networks. So in your syllabus, most of the unit is covered with the CNN. Already it was completed. Now unsupervised. Let us see the unsupervised pre-trained networks. What are they available? So all these are the unsupervised learning based. Actually, autoencoders, they are having two flavors. One is the supervised and unsupervised also. Autoencoders comes under the unsupervised in some flavors. And deep belief networks, we have to concentrate on this concept in this session. And the next one is the generative adversarial network, GANs. Okay, these are the three major architectures comes under the unsupervised pre-trained networks. So we are going with the deep belief neural networks. They are called the DBNs. So deep belief neural networks, it is the combination of the traditional network with the RBMs, restricted Boltzmann missions. A small introduction about that is the Boltzmann missions, actually they are the combination of the connections of various units of the network, meaning that there are no restrictions for connecting the neurons one to another, meaning that there is no layered architecture. All the neurons can be connected to other neurons in different strategies. So that is the Boltzmann missions. And a restricted Boltzmann mission means within a layer the network, the units cannot be connected each other, meaning that the units of one layer can be connected to units of next layer or the previous layer. That is the restriction. So it is the combination of the deep belief networks. It is the combination of the RBMs along with the traditional neural network. So actually RBMs, they are the unsupervised. They comes under the unsupervised learning, and our traditional neural network, it comes under the supervised learning. Meaning that first we will go with the unsupervised learning network, that is the RBM units, and then enter into the traditional neural network. So you can see that here DBN architecture. This is the diagram from the textbook we have taken. There are the input values. They will be given to the RBM units, and then they will be given as the input to the traditional neural network feed forward multi-layer perceptrons. So that can be shown in detail like this. See here, there are two RBM units mentioned, and the inputs are given to these layers. These are the unsupervised, and they can be given, they can take the data from the input layer and they will try to reproduce the same thing, so that they will extract the features of the input. They will produce some output. Thus, that output can be taken into the another RBM layer, RBM unit, and then after passing through different levels of the RBM layers, we can connect that output to the MLP, that is our regular multi-layer perceptron. Instead of giving the direct input directly to the MLP, we are giving the unsupervised networks, that is the RBM units. Why this is? Because see, this RBM unit, this will understand and it will extract the important features of the input, and it will be given to the next level, so that most important features will be captured, and the captured features will be given to as the input to the MLP, so that it can train well compared to the regular neural networks. So this is the idea behind this deep belief networks. So in this, the first part is the RBMs. From the RBMs, they will extract the high level features from the raw input vectors or the raw input images, whatever it is, the input. And what they will do is the RBM, actually the RBM is having two layers. One is the input layer, the second one is the hidden layer. So the hidden layer, hidden units of the RBM, they will take the raw input and they will try to reconstruct the same record whatever it has taken, and then it will generate something very close to the previous the input record, so that it will extract the features of the input. And actually this concept is called the dream about the data. Dream about data, it is the name given by the author. And then the purpose of RBM to learn the higher level features of the data set as the unsupervised training fashion. It is not the supervised, please remember this. There are two parts in the deep belief networks. One is the unsupervised block, second is the supervised block. Unsupervised block, RBM blocks, and the second one is the supervised block, that is the traditional neural network. So in this, the learning of the features, in the higher level, the learning the features by using the unsupervised fashion, and they will be considered as the pre-trained. Before training, we are extracting the features, that is called the pre-trained model. Okay, pre-trained phase, and each hidden layer of the RBM, they will extract the complex features as we discussed. And these higher order features, they will progressively combined in the non-linear ways in the next level, and then you can see that these are the inputs given in the for the unsupervised learning. In the first level, this is the network, this is the output of the first level of the RBM, and the second level we can extract this, and in the third level we can extract like this, so that these are the inputs given from the MNIST digit data set by the end of this pre-training model, and just before connecting to the regular MLP, we are getting the pre-trained features. Instead of giving directly the images, already we captured these images and we have given that into the MLP. These features will be given into the MLP. So we can go with the next level, that is after that initialization of the feed forward neural network, that will be initialized with the values of the output of the previous RBMs, and it will continue so that it can perform well compared to taking from the scratch and from the raw data. And fine-tuning DBN with with the feed-forward multi-layer neural network. That is, already by using the unsupervised learning, it was able to construct some data, some features, it captured some features. After that, it is given to the supervised learning model so that it can fine-tune. Only it can fine-tune that block. The unsupervised, it is over, that role is completed, and then we are coming to the feed forward neural network, that is the MLP, traditional MLP. There we can train the model, so that the first part cannot be trained, the second part can be trained. So because of this reason, this is called the gentle back propagation. And the pre-training phase, it will capture the features and it will give that as the input, and then the fine tuning, it will be very easy, and this can be used for the at the end of the network, so that it can be like the classification. It is it deals with the actual business rule, that is it may be the classification. Now you can see that gentle back propagation, the pre-trained with the RBM features, that they will be given to the neural network, a traditional neural network. They will capture the higher order features from the data, the pre-trained with RBM, and then that will be given as the initial starting values of the feed forward neural network, and then it will continue its training. So the training, the gentle training will be only for the neural network, this part. So because of that reason, it is the gentle back propagation. So after that, it will be connected to the output layer. Generally, it will be the classification. That may be the logistic regression or classification, like that. And actually, these networks we are using the CNN for the capturing the features. So we are not concentrating much on these networks in the syllabus. We are concentrating on the convolutional neural networks that was already completed. Thank you.